In example 2.3, once again, we are adding two forces to determine the resultant. In this case, the resultant is to be projected along the positive y-axis. So here we have the directions of all three vectors, and we are missing two magnitudes. So we can have no more than two unknowns. And in this case, the unknowns are the force component and the resultant force magnitude. We've got the image included. In the setup, we've added the x and y axes. So we'll continue the setup by adding a 200 millimeter line that is located 30 degrees above the horizontal. And we'll add a line. This one I'm going to make a construction line because I don't know how long it's going to be. So I'm going to add a construction line, and this construction line will be located 45 degrees to the left of the vertical axis. And that finishes the setup. Now I can hide the example image and work from here. So we will project the force line that we know about. And now I have a component that, because it's triangle rule, will be added to the end of the existing line. So we'll add another line. And then I know that it has to fall here vertically. So the resultant has to be in the vertical axis. In order for this to work, this second component has to be in the same direction as the applied force. So this is the second component. And then the resultant goes from the tail of the first one to the tip of the second one. And if I hover over this point, it should show me that it is vertical over the origin. And I can measure that the resultant force is going to be 273 pounds. I used a 1-to-1 ratio in this particular example. So with 200 pounds applied up and to the right, another force pulling at 45 degrees, that second force would have to be 245 pounds, and the resultant force would yield 273 pounds.